Okay, guys, there are 3 sorting algorithms and 2 search algorithms. Okay, and I told you that you should know the logic, okay, how it works, okay, how each algorithm works. It is very important. So at first, selection sort. Okay, there are 3 sorting algorithms: insertion, sort, and bubble sort. Okay. I'll use the same example to show the difference between the 3. Okay, between the 3 sorting algorithms. Okay, so I'm gonna have 5 data. Okay, I try to make as simple as possible. So let me have some more space here. Okay, so this is the data in the array, okay, to sort. Okay, and then this is A. This is A. Okay, this is array A. Okay. This is array A. Okay, and it is like this, 0 to 4. Okay, from 0 to 4. Okay. And the index starts from 0 always. Okay, always. Okay. Okay, then let me copy this one and paste it for the insertion sort and for the bubble sort. So I have 3 same data. Okay. Okay, so now I have same data. Okay, and I'll show you what happens using selection sort, insertion sort, and bubble sort. Okay, let's start from selection sort. Okay, selection sort. So at first we should know how to swap data. Okay, so at first when I is 0, you should find the smallest number. Okay, I think I repeat this. This is a 3rd time. Yeah, because I will have some questions in the final, okay, related to this kind of thing. Okay, so when I is 0, find the smallest one, and this is the smallest one, right? This is the smallest number, okay? So swap this smallest number with number at I0, okay? So the smallest number will be at 0. So 2, 9, 3, 2, 7. Yes, 2 and 7 are swapped. So this is the array. Okay, this is the contents of array after swapping number 2 and 7. Okay, so find the smallest one and swap it. Swap it with number at 0. Okay, and at I is 1. Okay, now I is 1. Okay, find the next smallest one, and at this moment we can assume that we have smallest number at 0. Okay, so we will not touch this anymore. Okay, yeah, we will not touch 2 anymore. Okay, okay, and when I is 1, find the smallest number among these 4. 3 is the smallest one, right? 3 is the smallest one. So swap 3 with number at 1. Okay, so 9 and 3 are swapped. 9 and 3 are swapped. Okay, so 2 stay the same. 3, 9, they swapped. Okay, 3, 9, they swapped. And 7, 5 stay the same, right? They stay the same. Okay, then now we have 2 data, 2 numbers are sorted. Okay, 2 numbers are sorted like this. Okay, and then I incremented by 1, I becomes 2. It means that find the next smallest one and put the smallest one at 2, right? So find the smallest one. It is 5, right? So computer will swap 9 and 5. Okay, 9 and 5. So they swapped. They swap. Okay. So when I is 2, the array looks like this. 2, 3 stay the same. 5, 9. They swapped. 7 stay the same, right? So now we have 3 numbers are sorted. Okay, 3 numbers are sorted. Okay, and then I is 3. Okay, now I is 3. So I is 3. Okay, then find the smallest one here. Guys, look at this one. This is the smallest one, right? And smallest one is in the correct location. In the correct location, it is at I3, right? So we don't need to swap, right? We don't need to swap because 7 is in the correct position. Okay, so when I is 3, no swapping. Okay, no swap is needed. And 7, 9. And we can say that 2, 3, 5, 7 are swapped, right? Okay, and look at this one. There are n number of data. Okay, there are n number of data here. Okay, there are n number of data, n number of data. Okay, and if n minus 1 data are sorted, then the largest one will be at the end, right? Because every time we find the smallest one, we swap, right? So the largest one will be at the end. So the sorting algorithm stops. Do you understand? So this is the process. This is a process of selection sort. Okay. Rune, no, it is not. Yeah, it is not. Okay. I will finish this. Okay, I will finish the 2 sort algorithm and then, yeah, let's compare. Okay. So at first, you should understand each single algorithm, okay, before comparing, okay? After you have the clear idea of each sorting algorithm, then you can compare, okay? If not, it is very confusing sometimes, okay? So this is very obvious algorithm. Find the smallest one, swap it. Find the next smallest one and swap it. So find the smallest one and swap it with number at 0. Find the next smallest one and swap it with index 1, right? Find the next smallest one and swap it the number in index 2. Okay. Okay, then let's talk about this insertion sort. I want to use the same data, same input data, okay, to compare 3 sort algorithm. In selection sort, at first, we don't touch this one. Okay, we don't touch this one. Okay, and starts from I1. Okay, starts from I1. So when I is 1, we should check. This is the one, right? 9. Number 9 is at 1. Okay, so we should check 9 is in the correct position. Okay, if not, we should move 9 somewhere. Okay, in this case, we use extra space key. For insertion sort, we use extra space key. Okay, in the selection sort, there is no extra space. We only use array itself, right? So this is key variable. Okay, and then when I is 1, put the value at 1, which is 9, in key. Okay, put this number in key. So key has 9. Okay, and compare 9 with 7. So basic idea is that I told you. So for example, we have this partially sorted array. Okay, I have this partially sorted array. Okay, and here I have 3. Okay, this is the basic idea. See, this part is sorted, right? Okay, then we have key. We have a key here. Okay, it means that I want to find the location for number 3. Okay, and compare 3 and 13. Okay, and 13 is greater than 3. Then move 13 to the right. So this will be 13. 3 is gone. 3 is gone. And move on. Compare 8 and 3. 8 and 3. Okay, 8 and 3. This time 8 is still greater than 3, right? So move 8 to the right. So this will be gone and 8 is here, right? And move on. 6, 3, compare. 6 is greater than 3. Move 6 to the right. Okay, so now it is not 8, it is 6. Okay, and compare the next one. Next one is the one before. Okay, the one before. The currently compared one. Okay, so 5 and 3 compared. 5 is greater than 3, so move 5. 6 is gone. 5 is here. Okay, and then compare 4 and 3. 4 and 3, still 4 is greater than 3, so move 4 to the right. Okay, and then compare 2 and 3. Now key is greater than this number, right? Then it means that this is the place to put key value 3. So 3 will be here. Guys, can you see that? Okay, then after inserting 3, we have 1, 2, 3, 4, 5, 6, 8, 13. Right? Successfully we inserted this number at the correct spot. Okay, this is the basic idea. Okay, so at first there's nothing to do, so we are not going to start from 0, start at 1. No, all three problems can handle duplicate data. Okay, duplicate data. Okay, so yeah, just for clear understanding, I just have all different numbers, but you may put duplicate data. Okay, look at this one. See, 7 is less than 9, so there's nothing to do, right? There's nothing to do. It means that 7 should be here, 9 should be here. Okay, then we have same data. 7, 9, 3, 2, 1, right? No change. Okay, and we have 2 are sorted. 2 are sorted, right? And move on. I2. Okay, I2. Okay, and then this time key is 3, right? Key is 3. The value at this location, it is 3. So key has 3. And compare 9 and 3. 9 and 3. This time 9 is larger than 3, right? So we are going to shift 9 to the right. So now this is 9, right? This is 9, okay? And compare 7 and 3. 7 is larger than 3, so shift 7 to the right, right? So this is 3, this becomes 7, okay? And 7 is the first data, so we put 3 here, right? We put 3 here, okay? So after this we have 3, 7, 9. See that? 2, 5. Okay? And here we have 3 numbers are sorted. 3 numbers are sorted like this. Okay? And I is 3. And when I is 3, now the key is 2, right? Okay. Key is the value at this position. So I'm going to draw again here. Okay. So key is 2. Okay, key is 2. Okay, compare 9. Compare 9 and 2. 9 is greater than 2, right? So move 9 to the right. So 9 will be shifted. So this is 9. And 7 and 2 are compared. 7 is larger than 2. So 7 will be moved to the right. So 9 is gone. 7 will be replaced. Okay. Yeah, 7 will replace the position of 9. Okay. And then compare 3 and 2. Still 3 is larger than 2. So move 3 to the right. Okay. Move 3 to the right. Okay. And then we should put 2 here. Okay. So after this process, after this, we have 2, 3, 7, 9, 5, right? Okay, and after that, we have key 5. Okay, we have key 5. So here, we know that 4 data are sorted, right? 4 data are sorted. Okay, and next key is number at I4. Okay, number at I4. So this is 5. Okay, this is 5. This is key. Okay. Now we have new key value and compare 9 and 5, right? 9 and 5. And 9 is greater than 5, so shift 9 to the right. So this becomes 9. Okay, and do the same thing. 7 greater than 5, so 7 should be shifted to the right, right? And look at this one, 3 is less than 5. It means that this value should be inserted here, right? So finally we have sorted array 2, 3, 5 is inserted here, and 7 and 9, they are shifted to the right. Okay, so now we have sorted array. Okay, so the process seems very similar, maybe for some of you, but actually the logic is completely different. Okay, completely different. Okay, and finally, bubble sort. Bubble sort will compare two neighbors. Okay, two neighbors. Okay, we can think like that. It is a little bit different compared to. Okay, if the order is not okay, but this time it is okay because the smaller number, okay, smaller number is stored before the larger number, 7, 9. The order is okay. Okay, so there is nothing to do. Then compare next to neighbors. Okay. Okay, and this time we need a swap, right? We need a swap because 9 is greater than 3. So 7, 3, 9, 2, 5 will be saved in the array, right? And compare the next two. Okay, next two. Just move on to the right, move on to the right, okay? And now 2, 9, the order is not okay. We need a swap, right? Because 9 is greater than 2. So 7, 3 stay the same. 2, 9 should be swapped. 5 stay the same, okay? And then compare the next pair. Compare the next neighbor pair, okay? It is 9 and 5. We need a swap, right? Because the smaller number is at the end. So 7, 3, 2 stay the same. 9 and 5 should be swapped, right? Should be swapped, okay? Yeah. Yes, Rune, yeah, yes. So in this process, okay, usually this is called one round. Okay, this is called one round. Okay, so one round means use a loop, okay? By using a loop, we compare every neighbor pairs, right? We compare each neighbor pair. And if the order is not okay, then we swapped, okay? So after this, you will see that the largest value will be here, right? Because whenever the smaller number comes after some number, then we swapped, right? So the largest value will be at the end, okay? And then we do the same thing. We do the same thing with these 4. Okay, I'll show you this one. See, compare 7, 3. We need to swap, right? Because the order is not okay. So 3 first, 7 next, 2, 5, 9 stay the same. And move on. Compare next to 2. 7 and 2. They need to swap, right? So 3 stay the same. 2 and 7 should be swapped. 5, 9 stay the same. Okay? And compare. Next pair. We need to swap, right? 3, 2, 5, 7, 9, right? So we did all comparison, right? We did all comparison. Okay, excluding 9, right? So finally, 7 is here. So now we have 2 partially sorted array. Okay. Oh, I see, Rene. Okay. Yeah, but the idea is a little bit different. Okay, so look at this one. See, we find the smallest one and directly swap it. Yeah. Okay. Yeah, Rene. Okay, but it is not. Okay, just comparing neighbors, and if needed, swap, right? Comparing, swap, depending on the comparison. Oh, it is no story. So I just want you to understand, because if you don't major computer science, if you don't have any plan, then I think just understand this one is enough. Okay, but later in the more advanced course, you will learn more sorting algorithm. Okay, so I just want you to have a clear understanding of each sorting algorithm. Okay. Any question about this? And I told you that you should know this process. Okay, I'll ask your understanding. I'll ask your understanding of this process in the final. So I recommend you to simulate, simulate the sorting algorithm by yourself, just I did. Okay, just what I did here. Okay. Okay, great. Okay, then searching. Yesterday I talked about 2 searching algorithms, right? Yeah. One is, let me get rid of this one. Okay, one is sequential search. Okay, I hope you remember this one. There are 2 search algorithms. Okay, and you see that 3 sorting algorithms and the 2 search algorithms, they are all application of the array. The input is array. Do you understand? Input is array. Okay, there are 2 search algorithms. One is linear search. Okay, linear or sequential search. Okay, and second one is binary search. And the important thing is that binary search can be applied only to the sorted array. It means that if the array is not sorted, then we cannot use binary search. Okay, but linear search, it is okay for sorted array, non-sorted array. Yeah, any array is also okay for the linear. Okay, and in the linear search, let me have some data. Linear search is very straightforward. So if I have 7, 9, 8, 2, 11, 1, 5, 6. Okay, I have 8 data. Okay, I have 8 data. So look at this one. Guys, you should think about this one. Maybe you need this for the project. Okay, for the project. So look at this. I have 8 data. The index will be from 0 to 7. 5, 6, 7, right? Yeah. So there are 8 data. Okay. Okay. Target value means the number you are looking for, okay? Target value. If the target value is 2, okay? Okay, then you just compare. You just compare 2 target value with each single value in the array, right? So at first you should check, is this 2? It is not, okay? It is not, 7 is not 2. So move on, check this one. Check the value at 1 is 2 or not. Okay, it is not, move on, okay? So when you reach here, it is 2, okay? Then return value, this is a function, okay? Return value is 3, okay? Return value is the location, the index of the data, okay? So when you find the target value in array, then the index should be returned, okay? So input is array and target value, right? So we will find the target value in the given array. And if the target value exists in the array, then return the index, okay? And how about this one? If the target value is 3, okay? 3 is my target value. Then computer will do the same thing, right? Yeah, computer will check. Is this 3? No. Is this 3? No. Computer will go over each data one by one until it finds 3, right? And look at this one. It's not 3, it's not 3. So computer will compare all the way here, right? All the way here. And there is no more data. This is the end, right? No more data. And we couldn't find 3 yet. Then return value will be -1. Okay, return value means -1 means no target value in the array. Is it okay? Yes, this is linear search, binary search, sequential search, sorry. Linear or sequential search algorithm. Okay, okay. And binary search can be applied to only search the data. So let me have 2, 4, 5, 6, 8, 9, 12. Okay, I have 7 data. Let me make 10 data. It is too small to explain. Okay, and then 17, and the last one is 20. Okay, I have 4 data. So here I have 1, 2, 3, 4, 10. Yeah, 10 data. Okay, so this is A. Okay, guys, do you remember the algorithm for this? Okay. What is the first thing we should do for binary search? What is the first step? Anyone?
Find the mid index.
Okay, how do you find it?
The 0 plus the last one.
Last index. Okay, let me read the chat. Okay, add start index and n divided by 2. Okay, very nice. So it's the same thing. Okay, Yao, Luis, thank you. Yeah, okay. So at first you should have left and right. Okay, left is the leftmost index. So this is left. Okay, I'll just write down L. Okay, this is left index. And the largest index, in this case 9, is the right index. Okay, let's say this is R. Okay, okay, let me draw here. Let me draw like this. I want to see how many comparisons we need. So, okay, guys, look at this one. I want to make a table. Okay, and I want to keep value of left, right, and mid. Okay, M is mid. Okay, so at first, left is 0, right is 9, right? And mid is left plus right divided by 2. Okay, and in this case, it is 4, right? It is 4. 9 divided by 2 is 4 because they are integers. Then this is mid, right? This is mid. This is right. Okay, this is the first. This is the first middle value. Actually, it is a middle index value. Okay, this is the first middle index value. Okay, and then we need comparison, right? We should check at this moment. We should check. Let me have target value. I didn't write the target value here. Okay, let's have target value. Hold on. Okay, let's have target value 9. Okay, yeah, 9. So at first I want to see, yeah, 9 is in the array or not. Okay, yeah, I want to see 9. Okay, then at this moment, after this step, okay, after this step, computer will compare the data at 4, index 4 with middle data with target value, right? So computer will check a mid. Okay, the data at the middle index and the target value. 9 is the target value, right? Okay, and M is 4. M is 4. So it is 8, right? So this is 8. M is 4. Okay, M is 4. This is 8, right? So the target value is greater than the middle data, middle number, right? Then what should we do next? Yes, thank you, Luis. Correct. We should move. So this means that, guys, there's nothing to memorize. So look at this one. See, if this is true, if this happens, it means that middle value is less than target value, right? Then target value will be on the right side of the middle value, right? So target value will be somewhere in the right side of the middle value. This is a middle value. Okay. So we should find the next middle index. So we should move left to mid plus 1. Is it okay? So this will be new left, and this is not left anymore. Okay. So in the table, I can write this time left is 5. Okay. So this is 5. Okay. We can get this from mid plus 1. Okay, mid plus 1. Okay, and R stay the same. R stay the same. Okay, and then find the middle index. This time, left 5, right 9. Add them up, divide by 2. Okay, and it is 7, right? It is 7. Okay, and do the same thing. Compare A7, because M is 7. Let me write down 7 here. And 9 target value. And this time, A7 is 15, right? 15. Now, 15 is greater than 9, right? Okay, then what should we do next? Move right, yes. Update right with middle minus 1. Okay, so after this, we should update, okay? We should update right. Okay, so at this moment, this is new mid, right? This is new mid, and it's gone, okay? And then we should move right to mid minus 1, right? Because middle data is greater than the target value, okay? So now we have left 5, okay? However, right should be updated, right? Okay, so right is 6, and we get this by m minus 1, okay? M is 7, so m minus 1 is 6, that's why it is 6, okay? And find middle data using this formula. It is 5. It is 5, okay? So we need to compare A5 middle value, A5 with 9. And look at this one, A5 is 9, right? A5 has 9, okay? So this is the same. This is the same data, okay? Then we know that target value 9 is at index 5. And at this moment, return current middle value, right? Current middle value is M, okay? Current middle value, okay? So 5 is the output. 5 is the output of this algorithm. Is it okay? So as you see here, we need 3 comparisons. We need 3 comparisons. Is it okay? 3 comparisons. Okay? Yeah, binary is much faster. Yeah, I'll talk about that. Okay, yeah, binary. This is much faster. Okay.
So
Any
what-
question? Yeah.
What if left equal to right?
Left and right can be the same. Left and right can be the same. It can happen. It can happen. And yesterday example was that. Yeah, in the yesterday I talked about when the left and right, yeah, they becomes the 7. Okay.
Okay.
Okay. So anyway, I will talk about one more. Okay, I'll talk about one more.
Okay.
So, let me get rid of this one. Okay, so let me use the same data. Okay, and now I want to have target value. Let's have target value 3. Okay, 3. Yeah, I want to find the data that is not in the array. Okay, so at first this is left. Okay, it's the same thing. This is right. Okay, and this is the first mid. Okay, so let's have table. It's the same thing. So I'm going to have 3 columns, left, right, and mid. Okay, so this is left value, this is right value, and this is the middle value. And it's the initial data is left 0, right is array size -1, the largest index. Okay, and middle value can be obtained by adding left to right divided by 2, which is 4. Okay. Okay, so this is the first step, and computer will compare the data at the middle position, which is 8, right? So A4. okay? And target value. And this time A4 is 8. So this is greater than the target value, right? So we should move right index, right? So this means that, guys, there is nothing to memorize, okay? This means that target value is less than middle value, right? Target value is less than its value. It means that target value will be somewhere here, okay? Yeah, if target value exists in the array, then it will be on the left part of the array, right? Because all the right side of the middle value is greater than the middle data. And middle data is greater than target value, right? So we don't have to care about this, okay? So we need to move right index to mid minus 1, okay? So in the table, left is the same, okay? And right is mid minus 1, which is 3, right? Which is 3. So I got this by m minus 1, middle index minus 1, okay? And 0 plus 3 divided by 2 will be 1, okay? It is 1. Okay, then computer will compare A1 with 3. Okay, now look at this one. A1 is 4. A1 is 4, right? Still, it is greater than the target value. Okay, so we should move. So let me write down, this is not right. So this was new right, right? This is not the middle. This was the new middle, right? In the second step, 0, 0, 3, 1, right? So this is mid, this is right, okay? And we should move right one more time, right? Because still we don't know the target value exists in the array or not, right? So after this, here, see, this number, A1 is greater than 3. Okay, guys, excuse me, I need to close the window. Okay, so this time we should move right to mid minus 1. Okay, yeah, this is the case where left and right have the same value. Okay. So in this case, left 0, right? And right will be 0 because m minus 1, right? Because this calculation m minus 1. Okay, m is 1, m minus 1 is 0, right? So left and right, they have the same value. Okay, they have the same value. And we should find the middle data. Okay, middle data is also 0 because 0 plus 0 divided by 2. Okay, and it is 0, right? Okay, so finally, let me make this clean. So finally, I think you understand what's going on here. Okay, so finally, this is the situation. This is left, this is right, and also this is middle, right? See, 0, 0, 0. Okay, then computer will compare A0, right? A0 equals middle value, index value is 0, okay? And compare with target value. And this time, this is 2. A0 is 2, right? So target value is greater than middle value. What is next? Do we need one more step or this is it? Do we need one more step? I mean, do we need to calculate left, right, middle one more time or not? At this moment. You know that 3 is not here, right? Just seeing, yeah, just seeing this one, we know that 3 is not in the array, but computer does not know, right? Computer should compare, okay? According to the logic, okay? What will be next? Okay, guys, just think about this one. Okay, so in the coding, we should find the pattern. And it means that we should do the same thing over and over again while the condition is true, right? While the condition is true, we will do the same thing over and over again, right? So we find the mid and we compare the middle data with the target value. And depending on the result of the comparison, we updated left or right. Do you understand? Okay, and in this situation, we have new left and right, right? Yes, so, okay, Daniel, thank you. Yes, still we don't know 3 exists in the array or not. Okay, Daniel, you are correct. Okay, so we need one more step. Okay, so in this case, guys, look at this one. If this is the case, we should move left index, right? We should update the left index. Okay, and it is 1. Because left index should be mid plus 1. Okay, left index should be updated to with mid plus 1. Okay, mid plus 1. Okay, mid is 0. Okay, and right stay the same. And look at this one. See, left becomes greater than right. Right? And this is a condition. This is a condition where the loop stops. Do you remember that? The code is like this. While left is less than or equal to right. Okay, and then find mid index. Okay, and compare mid value with target value. Okay. Okay, and depending on this comparison, so
Yeah, so I didn't get it. This one, since array A0 is 2 and it's less than 3, so it should be left minus 1, right? Y is plus 1.
left should be incremented, right? Do you understand this one? Left should be updated, right? Is it okay?
Left should update it.
Yeah, left should be updated. And always left is updated with mid plus 1. Okay? When you update left always updated with mid plus 1. And when you need to update right should be updated always mid minus 1. Okay? So left should be updated. Then we must add 1 to the mid, and mid is 0, so it should be 1. Okay?
Okay.
And let me finish this, okay? So here, see, depending on this comparison, we need to update left or right. Okay? Yeah. This is the process. This is the, yes, algorithm, logic. Okay? So look at this one. This is the logic. Okay? So it means that if this is not true, okay, so if this is not true, then the loop ends, right? Yes. So the opposite of this one is left is greater than right. Okay, so when this condition holds, this condition, left becomes greater than right, okay, then it means that there is no target value in the array. Is it okay? So we know that there is no target value if this condition holds after this process, okay? Okay, then in this table, you can know that there are three comparisons, right? Yeah, there are three comparisons, okay? And then we conclude that there is no target value, okay? Okay, guys, then think about this one. See? Any question before I talk about more about this? Okay, so you should understand the algorithm, okay? And look at this one. Yes. Even if left and right is the same, okay? Then yeah, so even if the left and right are the same, we must check the middle value. Okay? Because see, look at this one. See? Less than or equal to. It means that if left and right are the same, okay, if they are the same, you should do this one more time. Okay? Only when left becomes larger than the right, then the loop will stop. Okay? Okay, and I told you that binary search is much faster than linear search. Okay, guys, think about this one. I have 1,000 data. Okay, I have array A. Let's say the array is sorted. Okay, the array is sorted. So every number is in the correct position. So I have a lot of data. Okay, a lot of data. 1, 2, 3, 4. And this will be 999. Okay. Okay, so this is sorted array. Okay, this is sorted array. This is sorted. It means that the smallest data will be at 0, right? This is the smallest data, and this will be the largest data. Okay, and guys, think about this one. I have some data, and the target value is given. Okay, you are given target value. Okay, target value x. Let's say x is the target value. Okay, if you use linear search, okay, if you use linear search, then how many comparisons do we need? Linear search. So let me write down here. We don't know what x is. Okay, so I want to make some general way. So sorted array. Okay, so given sorted array and one target value. Okay, and we don't know that target value is in the array or not. Okay, one target value. If the target value is not in the array, then -1 will be returned, right? Yeah, given one sorted array and one target value. At least 999. Okay, yes, Rune, very nice. Okay, then how many comparisons needed? Okay. So how many comparisons needed to find the target value? Okay, or decide target value is not in the array. Okay, if the target value is in the array, then index will be returned, right? If the target value is not in the array, then -1 will be returned. Okay, okay, so how many comparisons do we need? Okay, so it is at most 1,000 times. Is it okay? Because we don't know where the target value is. Okay, so maybe target value will be here. Maybe target value will be somewhere here. Okay, this is target value. It is in 600. Then we need 600 comparison, right? because we should check, is this target value, is this target value, is this target value, right? We should do this all the way up to we find the target value, right? So if the target value is at 600 spot, then we need to compare 600 data, okay? If the target value is here, for example, at the index 800, then we need 800 comparisons, okay? Yes. Yeah, Rune, you are correct. Okay. So at most 100 times. It is a linear search. Linearly compare everything. Okay, linearly compare everything. Okay. And about this one, see how many comparisons needed with binary search. Okay. This is linear search. The first one is linear search. Okay. So first one is linear search and the second one is binary search. Okay. Linear. Okay. Okay, so array size 1000. Okay, array size is 1000. Okay, given searched array with 1000 data. Okay, okay, and target value. Okay, okay, what is this? Rune, you wrote on the chat 9 or 10? Let me see. Okay, why do you think so? Do you have any reason 9 or 10? Can you say at most 9, at most 10? So maybe, yeah, at most 10, something like that? Okay, at most 10. Okay, what is the reason to say that? Cuts in half, cuts in half. Okay, very nice. Yes, yes. Guys, look at this one. See, okay, you are correct. Okay, so we have 1000 data. Okay, this is 1000 data. This is 0. This is 999. So left is 0, right is 999, right? And you will find the mid, right? 0 plus 999 and divide by 2. What is it? It is 499, I think. Yeah, 499 or 498, something like that. Okay, maybe 498. Okay, so anyway, this will be middle index, right? Okay, and you should compare this middle data with the target value, right? This is one comparison. This is one comparison, okay? After first comparison, you will choose one part. So if the target value is smaller than this one, you will ignore 500 data, right? You will ignore 500 data, okay? And then you will check this part, right? Okay, and then you move right index to here, okay? And find the middle. And after find next middle, you compare this number with the target value. If the target value is larger than this one, if the target value is larger than this one, we don't have to check this part, right? So after this, we will ignore about 250 data, right? Because the total of this 5,000, almost 5,000, right? The half. So 250 will be ignored. Okay. Okay. So at first we need to consider 1,000 data. After one comparison, we can ignore 500. So 500 will be remained, right? And after the next comparison, we will ignore 250 data, right? And then after this comparison, we will ignore the half, right? So after 250, we should check 125 data, okay? This is comparison. First, this is first comparison, okay? After first comparison, we should take half data. After the second comparison, we take half, okay? After the third comparison, we need to check only the half, okay? It goes this way. Yeah, half, okay? And after the first comparison, this will be 62, right? 62. And then it is about 31. Just half, just goes this way, okay? And then 15, right? 15. And about 7, about 3, right? About 2 or 1. It goes this way, okay? So this is about 1,000 data with 10 comparisons, at most 10 comparisons, okay? So guys, think about this one. See, we have 1,000 data. Okay, and in the linear search, at most we need 1,000 comparisons, okay? However, if we use binary search, we need at most 10 comparisons. It is very, very efficient and fast algorithm. Do you understand? However, to apply binary search, the array should be sorted, okay? Okay, so this is very important. Okay? Any question regarding this one? Oh, yeah. Yes. Yeah. Okay. And if you think, see, guys, look at this one. If I have 1 million data, okay? If I have 1 million data, then first data will be at 0, and the last data will be at 999,000, right? This is the index of the last element. If we have 1 million, okay? If we have 1 million data, okay? So if the array has this much data, then still we need at most 1 million comparisons for the linear search, okay? However, if you use binary search, it will be much, much faster. Do you understand? It is about 200. Yeah, it is correct. Yeah, it is about 200. Okay. Yeah, so in the binary search, so in the linear search, we need at most 1 million. Okay. However, if you use binary search, we need at most 20. Okay, you can check that. Okay, think about this one. So binary search is a very good algorithm, Okay. Okay, guys, any question about this? Okay, this is for section 7.3. Okay, so I covered chapter 7 is all about the array. Okay, so 7.1 is about some basic grammar of the array, and 7.2 I talk about how to use array in the function. Okay, in the function, and 7.3 is searching and sorting algorithm. Okay, and we have one more section. It is 7.4. Okay, 7.4. It is multi-dimensional array. Okay, so after the break, I'm going to talk about this one. And tomorrow, I think maybe, I need time, the whole time today for, finish this one. And tomorrow, I'm going to talk about chapter 6, file IO. Okay, I couldn't finish this one. Okay, we didn't have enough time. So I will go back to chapter 6 and then move on to chapter 8. Okay, because I should cover up to chapter 8. And chapter 8 also has a lot of stuff. Okay. Okay, guys, let's have some break and 150. Okay, 150. Okay, I'm gonna start 150 again. Okay, guys, let's start again. Okay, this time, section 7.4, multi-dimensional array. Okay. Okay, here. Let's review one-dimensional array. Okay, one-dimensional array. The one-dimensional array. Okay, and these are the examples of one-dimensional array. So look at this one. One-dimensional array is a data structure. Data structure means some collection of data. Okay, how to collect the data. Okay, and it contains a set of elements of the same data type. Same data type. Okay, you should specify which data type data will be saved in the array. Okay, so A has all integers. Okay, so for example, if n is 5, if n is 5, okay, I did not have this one, but n is 5. Okay, n is 5. Then I'm going to have 5 integers. Okay, 5 integers. Okay, then inside the memory, you will have this structure. Okay, this is data, very simple data structure. Okay, collection of data. And if you have cha data, cha is only 1 byte. So that's why I drew very small array. Okay, and you should provide 5 characters. Okay, 5 characters. Okay, and in the double, you should provide double data. Okay, and you know that integer is 4 bytes, char cha is 1 byte, and double is 8 byte, right? Okay, so these are examples of one-dimensional array. Okay, and let's talk about two-dimensional array. Okay, two-dimensional array. So you can think that two-dimensional array is a set of one-dimensional array. Okay, so look at this one here. This is a grammar here. Integer. Okay, integer. And this is the array name. And look at this one. I have two brackets. Two brackets. So in the one-dimensional array, I have only one bracket, right? Int a, one bracket, just like this. This is one-dimensional, right? This is one-dimensional, okay? So if you have only one bracket like this, then computer will create just one line, okay, one set of data, okay? In the two-dimensional array, you should provide two brackets, right? And first bracket, this is the first bracket. First bracket has information of the number of rows. It means the number of lines. Okay, row is a line. Okay, number of lines. And the second bracket has number of columns. Okay, number of columns, column information. Okay, so you should provide two dimensions. Okay, this is one dimension. There are two dimensions. Okay. Then inside the computer, if you create data like this is data array. And guys, look at this one. See, each row is size 5 one-dimensional array, right? So this is a row. This is the first row, okay? And the second row also has 5 elements. Third row is also, there are also 5 elements. Okay. And fourth row has also 5 elements. Each row has 5 elements, right? So you can think like this. There are 4 rows. Okay, 4 rows. And each row is size 5 one-dimensional array. Okay. So you can think like this. So there are size 5 one-dimensional array. Okay. Okay. We have this array of 4 rows. Okay. So 0, 1. Okay. Another size 5 one-dimensional array. Another size 5 one-dimensional array. Okay. And another size 5 one-dimensional array. Okay. So finally, you will get this structure. Okay. So remember, the first number is number of rows, number of lines. Okay, and the second dimension is number of columns. Okay. Okay, and in the one-dimensional array, if you create int a5, then computer will make 5 spaces, right? Computer will make 5 spaces. And index is 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. And you can use this cell. So if you want to put data at 3, then you must put data. I want to put 5 here. You must do this, right? Yeah, so 5 should be saved at A3. So 5 will be saved here. Okay, so like this, okay, like this, two-dimensional array has number. Okay, some kind of some specific number for each cell. So look at this one. There are 20 cells, right? There are 20 cells because 4 lines and each line has 5 cells, right? So total there are 20 cells and each cell has a number. Okay, so look at this one. This one is 0 row, 0 row, 0 column, right? So the number of this cell is 0, 0. Okay, and look at this one. This cell is line 1. Okay, row 1, column 3. Okay, row 1, column 3 meet in this cell. So this cell is 1, 3 cell. Okay, yeah, this is a way how we put the some, it is not a name, but yeah, put some special specific location information for each cell. Okay, row and column information. Okay, so after this, if I have data, for example, 3, 1, 3, 1. Okay, I want to put 100. I want to put 100 at data 3, 1. Then computer knows that 3, 1 is this one, right? This is 3, 1 position. Okay, the cell of 3, 1. Okay, so computer will put 100 here. Is it okay? Yes. This is two-dimensional array. We can make a three-dimensional, four-dimensional array, but it is very complicated. But two-dimensional array is very useful sometimes. Okay. Okay. So here, see, there are two index. Okay, two index values. So 0 to 3 is row index. 0 to 4 is column index. Okay. Oh yeah, it is true. Yes. So we are going to use this a lot. Okay, but there is some bad thing about this one. I'll explain this later. Okay. So at first you should know how it looks like and how we create and initialize, or always how to make it, how to initialize it. Initialize means save the data for the first time, right? Yeah, and then how to manipulate the array. Okay.
So does this arrays have to have same data type?
Oh yeah, because we should specify data type first. It means that all spaces, okay, all spaces will have integers. Okay.
Okay, thank you.
Array always have all the same, the same data type. Okay, this is an example. Look at this one. See, a little bit more, complicated than one-dimensional array, but nothing special. Okay, So here, data for 3. So 4 rows. This is data. Okay, this is data. I have 4 rows and 5 columns. Okay, so 1, 2, 3, 4. Actually, index 0. Always index is a start from 0. Okay, so row 0, row 1, and this is row 2, row 3. Okay, and then column 0, column 1, column 2, 3, 4. Okay, and look at this one. See, we need nested loop. Okay, you should understand this one. Okay, so here, when I is 0, okay, when I is 0, and this is true, this condition is true, right? I is less than 4. So computer will execute this nested inner loop, right? And J is 0. Okay, j is 0. Okay, and then it is true, so data, let me write down here. So at first I is 0. Okay, at first I, let me write down I and j. Okay, so at first I is 0. Okay, at first I is 0. And then j will start from 0 and it will go up to 4, right? Less than 5. So j will be 0, 1, 2, 3, 4. Okay, and while updating j, we will put I times j in this location. Okay, so at first 0, 0, right? And this will be 0, right? Data 0, 0 has 0 times 0, so it is 0. Okay, and I stay the same. J will be incremented by 1. 0 times 1 is 0, right? And 0 times 2 is 0, right? And 0 times 3, still 0. Okay, and 0 times 4, still 0. And look at this one. I is 0, and when j becomes 5, this is false, right? This is false, right? This is false. So computer control will go here, outlook. Increment I by 1. I becomes 1, right? I becomes 1. And start all over again for the next loop, right? So j starts from 0. So 0 again, okay? So 1 times 0 is 0. Do you understand what's going on here? And I is 1. J is incremented by 1. 1 times 1, now it is 1. I1, j becomes 2. 1 times 2 is 2, right? So in this way, 1, 3, 1, 4, 1, 5, okay? So 3, 4 will be saved here. And then when j becomes 5, it is false, right? It is false. J is less than 5. So go up. I will be incremented by 1, so I becomes 2. And start all over again from here. J is 0 again. Do you understand? And then, so this is just each cell, okay? Each cell will have the result of multiplication of row and column, okay? 2 times 0 is 0. 2 times 1, 2 times 2, right? 2 times 3, and 2 times 4. It's the same, 3 times 0, 3 times 1, 3 times 6, okay? 3 times 3, 3 times 4, okay? So in this for loop, I just fill the array, okay? I just fill the array by multiplying I times j, okay? Yeah, Luis, yeah, it is correct, yeah. But usually we separate input, output, okay? So this is the input. This is the input. Yeah, if you want to, you can have C out here. You can have C out here. Okay, but I just try to separate input part and output part. Okay, yeah. Okay, so after that, okay, so I fill the array. Okay, so this part, fill the array. Okay, fill the array. Because if you separate input and output like this, it is much easier for you to manipulate. Do you understand? Yeah, fill the array. Sometimes we need to fill the array some different way, some complicated way. Okay, if you have a cout, then it is very confusing sometimes. Okay, so it is nice. Fill the array and then cout, print out the array. Okay, so input, output, I just separate them. Okay, so after this, if you print out, see, I use ZW, okay, for the format. So after this, when you print out the array, you should have this one. Is it okay? This is two-dimensional array. Very simple example how to fill the array and how to print out the array. Okay. Okay, and you know that it is nice to have constant information for the size of row and column, right? So here, const int row 4 and const column int column 5. Okay, then I can declare using row and column, and I can use row instead of 4. I can use column instead of 5. Okay, it is very nice. It is very nice, right? Because if the row and column values are changed, okay, then I need 2 more rows. So if you just put 6, then all row will be 6. Okay, so this is very nice. Please use constant data, okay, for the size of an array. Okay, so the code is exactly the same with the previous slide. I only changed I only put this one. Okay. Okay, and this shows how to initialize two-dimensional array initialization. Okay, let me review one-dimensional array first, and then I'll talk about this one. See, int a, let's say 5, okay? I think it would be nice. Const int n 5, int a n is like this. Okay, yeah, this is the how to initialize it. Okay, or you can do this. I want to make 5 spaces and I want to have 5. Okay, and int a n. I just have 5. Okay, they are all good. Okay, they are all good. Okay, so computer will create 5 spaces. This one, 5 spaces, and 5 spaces will be filled with 5 numbers. Okay, this is initialization. So for 5, 3, 7, 2, right? Okay, and this one, see, I have 5 spaces, but this time I have only 2 values. And you know that 3, 5, and all the rest spaces will be filled with 0. Okay, filled with 0. Okay, and it's the same. I have 5 spaces, and this time 5 will be at 0 index, and the rest 4 spaces will be filled with 0, right? Okay, this is initialization. Okay, and when you don't have, so at first look at this one. This is an error, right? This is an error. Okay, you should provide the size. If you don't want to provide size, okay, no number in the bracket, then you must initialize like this. Okay, then at this moment, computer will, here, this one, okay, computer will check how many data in the curly brace, okay, and there are 1, 2, 3, 4 data. Then computer will create A with 4 spaces, right? So 3, 5, 6, 9 will be saved here. You remember that? Okay. So this is the initialization of a one-dimensional array. And actually two-dimensional array is the same. However, look at this one. In the two-dimensional array, see, this is an array. Okay, this is an array. So you should have array symbol. Okay, and this is a semicolon. Okay, and look at this one. 5 row, 3 columns. Okay, and each row is one-dimensional array, right? Each row is one-dimensional array. So look at this one. See, each row is one. This is one-dimensional array, right? Yeah, one-dimensional array initialization. Okay, this is one-dimensional array initialization. So, see, I have 5 one-dimensional array initialization. Can you see that? This is one-dimensional array of size 3, right? This is one-dimensional array of size 3, right? So you can see that here there are, you can see that there are 5, okay, one-dimensional array, right? there are 5 one-dimensional array here, right? Okay. And you must have comma, okay? Then this will be 253. 253 will be saved at 0, row 0. Okay, and 478, next 3 data, this one will be at 1. Next 3 at 2. Next 3 at index 3. Is it okay? So this shows how to initialize two-dimensional array. Okay. Any questions so far about this? No problem then. Okay, let me move on. Okay. Okay, and when you print out, you need a nested row. Okay, you need a nested row like this. Okay, you need a nested row. I think this is the same thing. Okay, look at this one, see? Okay, this is initialization. This is another initialization. Okay, guys, look at this one. In this case, this is 4. This is 6. Okay, 4 rows and 6 columns. Okay, so in this curly brace, I have for one-dimensional array. Okay, and this means that each row has 6 data, right? So this means that there are 4 rows, right? There are 4 rows, right? And each row has 6 columns, right? Each row has 6 columns, 6 data, okay? And here, I have only 2 data, okay? I have only 2 data in the first row. Actually, row 0, right? Row 0, okay? Then 1 and 2 will be saved here, and then all the rest spaces will be filled with 0, okay? This is the same. This is row 1, right? So this will be saved at row 1. And there are 4 numbers. So 4 numbers, 3, 4, 5, 6 are saved. Okay. And the remaining cell will be filled with 0. There is only 1. Then only 1 data, 7, is stored. And all the rest will be filled with 0. Okay. And there are 6. So all 6 numbers will be in row 3. Okay, so this is also possible initialization. Okay, and then we print out, okay, each row and column. Okay, any question about this initialization? Okay, then it is not that hard, right? Yeah, just be careful not to have some errors. Okay, and guys, look at this one. When you yeah, so always it is very important to know that the garbage value. So int A, int B 5, int A, let me have a small array, okay? Int, okay, and int B 2, 4. Okay, guys, look at this one. See, here A has garbage value, right? So here I create A, and here I have garbage, right? I have garbage, trash, okay? So garbage means useless, okay? Yeah, unwanted data, something like that, okay? So initialization is very important. When we initialize the space, then the garbage will be removed and the initial value will be saved. So it is very clean data, okay? And this is the same if you create array without any initialization, then computer will create 3 spaces, 0, 1, 2, Okay, and then all three spaces will have garbage value. This is garbage, this is garbage. Okay, this is garbage, some trash. Okay, and this is the same. This will create 8 spaces, right? 2 rows and 4 columns, right? So 2 rows and 4 columns. So total 8 data space. This is 0, 1. This is 0, 1, 2, 3, right? Okay. And all 8 spaces will be filled with all garbage value, Okay, that's why initialization is very important. Okay, and look at this one. See, in this slide, remember this one. I think you remember this one. If I put 0, only one number, okay? Even if this is a one-dimensional array, it is okay. Okay? Yeah, if you put only 0 with curly brace, even if it is two-dimensional array, then computer will create 4, 6. 4, 6 size is 4 rows and 6 columns, right? 6 columns. Okay, 4 rows and 6 columns like this. Okay. Okay, so there are 24, total 24 spaces, right? 24, okay? All 24 spaces will be filled with 0, all 0, all 0. Is it okay? So it is very nice to clean, okay, to clear the memory space, okay? And remove all the garbage, okay? So I just put 0 and then I just check my memory has all 0. Okay, and this is the output. This is the output. Yeah, it is a matrix. Yes. Yeah, it is a matrix. Yeah, it is exactly. Yeah, matrix. Okay. Yeah, this is called matrix. Two-dimensional array is a matrix. Okay, any question about the initialization so far? Okay. Okay, and guys, look at this one. See, in this example, I have, see, 4, 6. 4 rows, 6 columns. Then computer will create 24 spaces, right? 24 spaces. So it is 4 lines and 6 columns. Okay, 6 columns like this. Okay, 6 columns. Okay, and look at this one. This is first row, right? So first row will be 1 and there is no more. So computer will fill all 0. Okay, fill all 0. Okay, and this is the same thing. The second row has 1 data, so this will be 2 and the rest will be all 0. Okay, the rest will be all 0. Okay, and then there is no more. However, once we have some partial initialization, then all the rest of the data space will be filled with 0. Okay, yeah, so the rest will be all filled with 0. Okay, so there are many ways to initialize. Okay, okay, and look at this one. See, we can check that we have this structure, this data. Okay. Okay, let's have some practice here. Okay. Look at that. This is multiplication table, right? This is multiplication table. So I think we did this before. At the time, we just used a row. We did not make a table. Okay. Yeah. So nested row is very important for the two-dimensional array. Okay. So I want to create this space first. Then I want to set the value. Okay. Okay. Hold on. I think, yeah. Okay, let me show you. Okay, I want to make this one. Okay, guys, look at this one. I want to show the code for this one. See here. Always the index start from 0. Okay. So at first you should make 10 by 10 matrix, 10 by 10 two-dimensional array. It means that 10 rows and 10 columns, right? Okay, and then I want to put 1, 2, 3, 4. This is multiple of 1. Okay, this line has multiple of 2, right? Multiple of 2. 2, 4, 6, 8, multiple of 2. And line 2, actually it is row 2, okay? I want to have multiple of 3, multiple of 3, multiple of 4, right? This way. Multiple of 5, okay? Multiple of 6, okay? And then I want to print out, okay? Yeah, so at first I want to, yes, I want to fill the table, okay? Fill this table and print out, okay? Okay, let's do this together, see? Okay, so here, at first, always include iostream using namespace, okay? And I want to use const int and 10. And I want to make a 10 by 10, n by n matrix, okay? So int main, first, create a two-dimensional array. Int, let's say it is n, multiplication table, okay? So n, 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 okay? And it is nice to have 0, then there are 100 spaces, right? 100 spaces. Okay, so I want to fill 0 for all 100 spaces. I just, yeah, you don't have to make your own namespace. Okay, yeah. If you have very huge project, if you have a lot of project, then yeah, maybe we need, okay? But you understand what namespace is, right? Yeah, I think it is enough for this class, okay? Okay, and then I want to fill the array, okay? So after this, I want to fill the array M, okay? Fill the array M, okay? Then we need for loop, right? For I is 0, I is M, right? Okay, let me make this like this way, okay? And for int, you understand what I'm doing, right? So ing will be the index for the array, okay? Okay, and I want to put the data. I want to put the data, and this is the fill part. Okay, I want to fill the data. Okay, what should be here? Guys, what should be here? I want to fill the data. It means that I want to make 10 by 10. Okay, 10 by 10 space. Okay, for the multiplication table. Okay, so there are 10 lines. Okay, 10 lines like this. And there are 10 columns, right? 10 columns. Okay, like this, 0, 1, 2, it goes this way, 0, 1, 2. Okay, let me see the chat. Luis, Lene, sorry guys, both are not correct. It is not correct. Henry, no. Okay, guys, look at this one. See, let me draw more. Okay, 3 and 4. Okay, so this line should have multiple of 1, multiple of 2. Do you understand? Yeah, so multiple of 1 will be filled here. Okay, multiple of number 1, multiple of 2, multiple of 3. Okay, it goes this way. Okay. Luis, no. So for example, so this is a multiple of 4, okay? So row 3 will have multiple of 4. Multiple of 4 is 4, 8, 12, 16. You understand what I'm doing? 20, right? Let me draw more. Okay, so I need 5 more spaces. 24, 28, 32, 36, 40. You understand what I'm doing? I want to make a multiplication table, right? Oh, Joshua, thank you. Yeah, Joshua, you are correct. Oh, Luis, yeah, it is okay. But okay, so let me talk about Joshua first. Okay. Joshua said we should have here M I J J I plus 1 times J plus 1. Very nice. This is the answer. Okay, this is the answer. Okay. Because the reason we should start 0 is that always index is 0. Okay, however, if you use just I times j, then the first line will be all 0, right? And this will be 0 too. And this is 2, but it is not correct, right? Yeah, so you should have I plus 1, j plus 1, okay? It is because the index is always start from 0. Is it okay? Okay. And as Luis said, so maybe, okay, this would work. So if you want to start from, let me write down here. For I1, then it should go up to n. For int j, the same, start from 1, and j will go up to n, j plus plus. Okay, then mij is I times j. Okay, guys, is this okay? Guys, is this okay? I just, yeah, okay. So this is my question. Is this good? Oh, okay. Let me fix this one. Oh, hold on. Okay, I fix it. Okay, I fixed it. Okay, yeah. So is this good? It should work.
No.
Okay, why?
Yes, it always start to fill from 0, index 0.
Yeah. So if you do this, look at this one. So you can see the difference, right? You can see the difference. This one and this one. Okay. Yes. Yes, Joshua, thank you. Yeah, you are correct. And okay. Yeah, Rene, yes, it is correct. We missed some line. Okay, guys, look at this one. See, if you use this, then I starts from 1. It goes up to n. Okay, so computer cannot fill 0 row and 0 column, right? So one line, and one line, this line. Okay, two lines will be excluded, right? And also there is one more problem. If it goes up to 10, okay, then the computer will fill data in row 10, column 10. There is no column 10, row 10. Row is from 0 to 9, right? 4, 5, 6, 7, 8, 9. There is no row 10. Is it okay? Yeah. So if you write the code like this, then the computer will try to fill this. Fill this. It is already off, right? Can you see that? It is already off. Okay. So you can miss this pink part, and there is no. This is out of bounds error. Okay. Guys, do you understand? So when you handle array, the index is very important. Okay, so this is the answer. This is the answer. Okay. Yes. So Luis, when you write an array, when you write a code for the array, okay, always if you want to fill the whole array, okay? Yeah, if your purpose is to fill the whole array, always start from 0 and less than the size. Start with 0, less than the size. And you should manipulate this part somehow, like this. Okay? This is very easy to understand. However, then you must handle this part. Okay? And if you handle this part, then it doesn't look like an array manipulation. Okay? However, if you have always start from 0, this is the size of an array, then people think that, oh, this is some array part. Okay? So please use always start from 0. Is it okay? Okay, so this is some practice for the two-dimensional array. And let me finish chapter 7 today. Okay, guys, look at this one. See, so I hope you type the code, okay, by yourself at home, okay, and see if you understand. Okay, let me talk about this one. Still, I saw some students, okay, still, I have some students who are confused with array and function, okay? So let me review one-dimensional array and function. And let's talk about two-dimensional array and function. Okay. So look at this one. Let me make very simple code here. Okay. So if I have void test int, this is an array. Okay. Then into main, if I have array, let's say have size 5. Okay. Yeah. And my code has a function call, okay, and a, something like that. Okay. The code does not have any meaning. I just want to show you the grammar. Okay, grammar. Okay, and void test int. Okay, guys, look at this one. See here. I don't have enough space, so I did not have IO stream, something like that, using namespace. But anyway, you know that declaration, and definition, right? This is function declaration, and this is function definition, right? Function definition, okay? And this part is function call, right? Yeah, function definition, declaration, and function call, they should be some consistent representation. So look at this here. See, when you call the function by passing array, only array name. Okay, only array name. Okay. But I still see some of you pass like this. Test A5. This is completely wrong. Okay, this is completely wrong. Okay, when you call the function, only name. Okay, only name. This is a grammar. Grammar is a rule. You should follow. You should keep. Okay, so only put array name. Okay, array name. Okay, and in the definition, you must have. This can be any name. Okay, this can be any name. Okay. However, you must have bracket. You must have bracket here. You must provide bracket here in the definition. Okay. And in the declaration, you must have data type and bracket as well. Okay, and the bracket as well. Okay. So this means that I'm going to have one array parameter. Okay, one array parameter. Okay, this is a grammar. This is a grammar. Okay, so array name in the function call. Definition, declaration, you should provide bracket. Okay, to let your computer know. Then your computer know that this is an array, not just one int. Okay, this is a one-dimensional array function, array and function together. Okay, and if you have two-dimensional array, then look at this one. Check this box. Okay, and look at this one. This is function declaration, right? This is function declaration. Okay, at the top, and this is function call. Okay, and this is definition, right? This is function definition, right? Okay, so we have three parts. Okay, and in this case, look at this one. When you call the function with two-dimensional array, this is two-dimensional array, right? This is two. This is two-dimensional array, right? In the function call, it's the same. Just put the name. Just name. Okay? Yeah, just array name. When you call the function by passing two-dimensional array. Okay, just array name. Okay. In the function definition. Oh yeah. Oh, I see. Why? Okay. Let me finish this one and I'll talk about that. Okay. Okay, and guys, look at this one. See, this is function call. Okay, this is grammar. And look at this one. My two-dimensional array size is 9, and it's 3, and it's 3. So computer will create this array. 3 rows, 3 columns, right? So this is A. 3 rows and 3 columns, right? This is A. Okay. Okay, and then in the definition and in the declaration, see, look at this one. You should provide 2 brackets. Okay, 2 brackets. 2 bracket means 2 dimension. Okay, so if you don't have this one, okay, so if you have only int bracket, if you have only one bracket, then it is a one dimension array. Okay, so it is an error. Okay, so you should provide information of 2-dimensional array. Okay, so you should provide 2-dimension information. So you must provide 2 brackets. Okay, 2 brackets. And in the definition as well, 2 brackets. And one more thing. The first bracket can be empty. This can be empty. The first bracket can be empty. Okay, you don't have to put this. Okay. However, you must put the size of the column. Okay. So this is not possible. So look at this one, void fill array int. Okay. Maybe some compiler will accept this one, but you must have, most of compilers want to size. Actually, this is the size of column, right? This is size of column. Okay. Okay. So the reason is that you must provide the size of a column. okay, is you should let the computer know the length of each line. Length of each line. Okay. So here I can say like this. So I can say that you should provide the length of row, each of row, okay, of two-dimensional array. Okay, this is a grammar. Okay. If not, computer doesn't know how to access two-dimensional array. Okay. So in the definition and in the declaration, okay, in the definition and in the declaration, provide size of column, but you don't have to put size of row. Okay. If, yeah, okay, Daniel first, okay. Yeah, if the n is local to the main, it is an error. Okay, it is an error. You must put n before this. Okay. Okay. And then Luis, yeah, yes, you are correct. Yeah, it is similar with the one-dimensional array. See, in the one-dimensional array here, I don't have to provide. Okay, I don't have to provide the size here. Okay. Yeah, you don't have to provide this row information. However, you must have column information. Okay. Yes. Yeah. Okay. So actually it is nice. So yeah, it is nice to have a constant data as global. We usually don't have many global variables, because if we have many global variables, then the code is not neat. Do you understand? Too many global variables make us confused. Okay. Yeah. So if you think this variable should be global because all functions will use that value, then it is nice to have global variables. Okay. So for example, like this, the size of an array. Okay. And the size of an array will not be changed. There is no way to change the size of an array. Okay, once we create an array. Okay. Okay, guys, any question regarding this one? And I told you that you should know the grammar clearly. Do you understand? So in this class, you should know how to write a code. It means that you should improve your coding or the thinking skills. Okay. Yeah, that's why sometimes I did not answer right away. Okay, I don't answer right away when you ask some questions, because I want to give some time to think by yourself and come up with some idea. Okay. And grammar is very essential. Okay, it's very essential. Okay, so this is a two-dimensional array and function. I think this is the last page. Okay, I want to talk about this one. Okay, I want to introduce three-dimensional array. Actually, we don't use a three-dimensional array. Usually, we don't use it. Okay, however, this is possible. This is possible as long as your grammar is okay. And look at this here. See, I have one more dimension. See that? Yeah, I have one more dimension. So it means that I have two-dimensional array. You can interpret it this way. Okay. So this means that I have two. This size two-dimensional array. Okay. So look at this one. This is 3 times 4 table, 3 times 4 matrix, 3 times 4 two-dimensional array. They are all the same. Okay. So you may say matrix, table. Okay. Two-dimensional array. Okay, they are all same term. Okay, yeah, they are all same term. Okay, so anyway, here I have 3 times 4. It means that 3 rows. 1, 2, 3. 1, 2, 3. Okay, 3 rows. and 3 and 4 columns, right? So this one, see? This means 3 rows, 4 columns, 2-dimensional array, right? Yes, this is 3 times 4 array, and this is another 3 times 4 array, okay? Because there are two 3 times 4 arrays, so I create 3 times 4 2-dimensional array, okay? And look at this one. See, this is an index 0, 1, 2, 0, 1, 2, 3. Okay, and this is same 0, 1, 2 and 0, 1, 2, 3. Okay, and we have one more index to say about the first 2-dimensional array, second 2-dimensional array. Okay, so this one, the first 2-dimensional array is 0 array. Okay, number 0. Okay, and this is the same. This is another 3 times 4 array. Okay, this is 1. Okay, number 1 array. Okay, is it okay? So after this, so at first you should know how we put the index. Okay, and after that, if I use A, 1, 2, 1, I want to put 10. Okay, I want to put 10 at this position. Okay, then A1, this is 1, right? This is 1. Okay, and 2, 1, this one. So computer will put 10 here. Is it okay? So this space will get 10. Okay. Okay, any question about the 3-dimensional array? Yeah, you can make a 4-dimensional array. You can make a 5-dimensional array, but it is very complicated. So look at this one, see? Let me show you. Yeah, because some of you are curious about this one. So let's have, guys, look at this one. Int A, 2, 3, 2, 4. This is 4-dimensional, right? Then think about this one. See, I have 3 2-dimensional, right? 2, 4. So look at this one, 2, 4. 2, 4, 2-dimensional, right? And I have 3 of them. I have 3 of them. Okay? Just expand. Okay, based on the same idea. See? This is 0, 1, 2, right? And each table has its own index, right? 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and this is same, right? And this is same, right? Okay. And we have 2 of them. So, see, we have 2 of these, right? Then I should make one more 3-dimensional array, right? Like this. Just expand the size. Okay. And this is 0, 1, 2, right? And look at this one. See, this one, these 2. This is 0. This is 1. Okay. So after this, if I want to put data, 0, 2, 1, 2. I want to put 100 here. But it is very complicated. Okay, yeah, I just want to show you how we can expand the dimension. Okay, how we can do it. Okay, so look at this one, 0, 0, 2, 2, 1. This is 1, right? This is 0, 1. Okay, and 2, 0, 1, 2. So this space is this one. So I should put 100 here. Is it okay? Oh yeah, Luis, it is correct. Yes. We usually don't use it. Yeah, we usually don't use it. It is very complicated. And look at this one. See? If you want to fill the data, okay? If you want to fill the data, then what should you do? How many nested loop do we need? You can imagine. 4 nested, right? Right? So for one-dimensional array, we need only one for loop, right? 2-dimension. For the 2-dimension, we need 4 and 4 nested loop, right? For 3-dimension, we need 4, 4, 4 if we print out. Okay. So for example, if we have all data, okay, so all tables are filled with some numbers. I initialize it, and I want to see the numbers I want to print out. Then you need nested for loop. 4, 4, 4, 4. Is it okay? Yeah. So it is not a good idea. Okay. So actually, grammatically, okay, so this is possible. This is possible. Okay, in C++. However, we don't use it. Okay, guys, I have a question. I have a question. This is not a, let's start with 0. Okay, and let's have M. I don't know what M is, but M is some number. N is some number, some integer number. Okay, I have 2 codes. Okay, this is 1. Okay, and this is another. Okay, there are 2 codes. Okay, this is number 1 and this is number 2. Okay, so guys, assume that the code number 1 and 2, this is number 1 and number 2. Okay, number 1, number 2, 2 codes give the same result. Both are okay. Okay, both works fine. Both work correctly. So both will give you correct output. Okay, in this case, which code is better? Which one is better than the other? Number 1 or number 2? And the output is the same. Okay, so output is the same. Only the style. Which style is better? Okay, Rune, Luis, Rune, Gia, Daniel. Is there anyone who thinks number 1 is better? Okay, why do you think number 2 is better? So it looks, yeah, Yao, you can say that.
You can have less circle.
Less circle. What do you mean the less circle? Less repetition?
Yeah, less repetition.
Oh, okay, I see. Okay, then guys, think about this one. If M is 10, if N is 5, how many repetition? How many repetition do we need? How many repetition we need? For number 1 and 2 each, respectively. Okay, I understand when you're talking about Luis and Rene. Okay. Okay, guys, then let's talk about the actual number of repetition. Okay, if M is 5 and M is 10, N is 5. Okay, 10 and 5. Okay, Yeah, how many iterations do we need? See, we need, so it means that this part, okay, this part will be repeated 10 times, right? This part will be repeated 10 times. Yeah, it is 15, right? And this part will be repeated 5 times, right? 5 times. So total 15. 15 times of execution, right? 15. So all of you are correct. Okay, then how about this one? M5. Yeah, M10 and 5. Okay, this is the same. Yeah, this number will be applied to both 1 and 2. Okay, then how many times this part will be executed? Is it 15? Is it 10? Yes, Henry, Daniel, thank you. It is 50. See, when I is 0, okay, this line, this part will be executed 5 times. 5 times. When I is 1, this part will be executed 5 times again. When I is 2, this part will be executed 5 times. And I will go up to 9, right? So actually it is total 10. Okay. So this part will be executed 5 times. Okay. And total will be 50. Okay. Total is 50. So guys, now compare. If you use this one, we need 15 repetition. In this code, we need 50 repetition. Okay. It doesn't matter. Rene, it doesn't matter. Yeah. It doesn't matter. Okay. So think about this one. If m becomes large, okay? So if m is 100, if n is 1000, then the difference will much bigger. Okay. Yeah, amount of repetition. Okay. Actually, it's not. Yeah, okay, guys, I understand the one you are talking about. Yeah, actually, I think maybe, yeah, Luis, you're talking about what if I have, oh, okay, so maybe, I think maybe some of you think this one. So what if I have, let me change the color. Okay, so what if I have 100 lines here? Okay, yeah, 200 lines here, maybe 50 lines here. I think maybe some of you think about this one. Yeah, if the code 2 has much smaller number of lines, then this will be faster. Some of you may think like that. Okay, yeah, but we don't count the number of lines. We only count how many loops will be executed. 10 times loop, if m is 10. 5 times loop, right? 10 times loop, 5 times looping. So total 15, okay? 10 times loop outside, inside 5 times. So total 50 times of the looping, right? Yeah, in computer science, so we check the efficiency this way. So this will be much better. This will be much better code, okay? So based on this, okay, based on this, if you use a lot of nested loop, for example, like 4-dimensional array, okay, so for example, 4-dimensional array, so int a, so 2, 3, 4, 5, then you must have a 4. You must have 4. You must have another 4. Okay? Then this will be very slow. This will be very slow code because there are a lot of repetitions. Okay, that's why we don't use 3-dimensional, 4-dimensional array, even if it is possible in C++. You may have a 5-dimensional array, 6-dimensional, all are possible, but it is very slow because of the number of repetitions. Okay, I want to talk about this one. Okay. Okay, so we should find some other way to handle. If you need this, okay, we should think about some other way to handle this situation. Okay, and actually it is, yeah, the contents about this will be handled in CS3A a little bit, and CS8 is all about this. CS8 is all about this kind of thing. Okay, yeah. So I told you that in CS2 class, in this class, I just want you to improve your coding skills. Okay, and CS3A, you will learn some advanced topics of C++, pointers, classes, templates, something like that. Okay, and then CS8, you will learn how to improve my code. Okay, yeah. So running your code, get the correct output is the baseline you should have. And upon them, you must know how to make my code as possible as, yeah, okay, you understand? Yeah, I teach CS8 only fall, not spring. Okay, yeah, only once a year. Okay, one semester. Okay, anyway, this is the all about the array you should know in CS2 class. Any question? Okay, guys, and today's lab is pretty easy because I want to give you more time to the project. Okay, so
And for our project, can we use 2-dimensional array for?
no, you don't have to. Only one.
Okay, all right. Yeah, I'm still thinking about menu 5.